Hi, this is Leetcode question. Minimize the maximum difference of pairs. Now we need to return the minimum maximum difference among all p pairs, and because we are trying to minimize the answer, let's take any number from the array. Let's take number 2. Now what are the other two numbers that 2 can be paired to and the difference is the minimum? The answer is the first number that is greater than or equal to 2. In this case it's 3, and the first number that is less than or equal to 2 is 1. Now if you take the difference between 3 and 2, it's 1, and between 2 and 1, it's 1. Now these two values are the minimum possible difference if we want to include the number 2, and this is correct because if you try to take any other value, let's take 10 minus 2 equal 8 is greater than these two values. If you take 7 minus 2 equal 5 is still greater than these two values. So in order to get the minimum difference, possible differences, we took one value greater than or equal to 2 and one value less than or equal to 2. Let's take another number, for example 7. Okay, for 7, what are the values or the two values that 7 can be part of to or 7 can be paired with and the difference is minimized? The answer is the first value greater than 7 is 10. The first value is less than or equal to 7 is 3. Now 10 minus 7 is 3. 7 minus 3 is 4. So these are the minimum possible differences for pairs that 7 can be part of. In this case the pairs are 7 and 10, and in this side is 3 and 7. So 3 7 give us 4, 7 10 give us 3, and these are the minimum possible differences. Now if you try to take any other value, it will be greater than or equal to these values. For example, if you take 1, 7 minus 1 equals 6. 6 is greater than 4. If you take 2, 7 minus 2 equal 5. So 5 greater than 4. So notice this pattern: 1 2 3, and here we have 3 7 10, and so this tells us that we need to sort the array in order to find the solution. Now this array, after sorting it, become 1 1 2 3 7 10. Now notice every number can be part of the number in the right or the number of the left. So every number can be paired with right or with left. Okay, now if we ask this question, assume the maximum difference is 2. How many pairs can we get from this array in which the differences is less than or equal to 2? Let's see. We will go greedily in this array. First, I, we start from here. This is I, and let's have counter C initially 0. Now I with I minus 1, the difference is 1 minus 1 is 0. Now 0 is less than 2, and so this pair is good. We can take this pair, and we increase the counter by 1. And because now 1 is already part of this pair, next we will not move I to this and compare 2 with 1, because 1 is already part of this pair, is already taken. We increase I, so I is here. Then we compare I with I minus 1. This is I minus 1. 3 with 2. The difference is 1. Is 1 less than or equal to 2? Yes. So we increase the counter 2. And again, we move I not here. I will be here. I with my I minus 1. 10 minus 7, 3. Now 3 is greater than 2. So this is not valid pair. At the end, we get two pairs that can have difference at max equal 2. And here p equal 2, and so this number c is greater than or equal to b. In this case it's equal, and so this solution is a candidate solution, candidate answer. Now we need to see if a smaller number can also work, because we want to return the minimum maximum. Let's look for a smaller number and see if it can give us also an answer. Let's find the number of pairs that can give us maximum difference equal to 0. So the difference should be less than or equal to 0. Let's start with I here. I with I minus 1, the difference is 0, and this is less than or equal to 0, so the counter initially is 0. We increase it by 1. Then we move I here. 3 minus 2 is 1. 1 is greater than 0, so this is not valid pair. Notice in this case, because 3 is not included with this pair here, 3 is not part of it, we don't move I here. We want to see if 3 can be part of next I. So now I is here. We compare 7 with 3. 7 minus 3 is 4. 4 is greater than 0. This is also invalid pair. Then again we move I to the next one. 10 with 7, the difference is 3, which is greater than 0, so also this pair is invalid. Now at the end, C equal 1, so we got only one pair, but we need at least 2 pairs. So that means if this is the maximum difference, we will get only one pair, so this is not an answer. Previously we tried with 2 and it gave us an answer. 0 it did not. Let's try with 1. What if the maximum difference is 1? Let's see how many pairs we can get in which the difference is less than or equal to 1. We start with this I and we compare I with I minus 1. 1 minus 1 is 0. 0 is less than 1, so we increase the counter by 1. Now because this pair is valid, we don't move I here because 1 is already taken. I come here. Now 3 and 2, the difference is 1. 1 is less than or equal to 1, and so this is also valid pair, and we increase the counter by 1. Next I is here. 10 and 7 is 3, the difference, and this is greater than 1. and that means this is invalid pairs, and we are done with this iteration, and the answer or the counter equal 2. So we managed to get 2 pairs when the max difference is 1, and so this is the valid answer, because 2 give us 2 pairs, 0 give us 1 pair, so it was invalid. Now 1 give us 2, and so this is valid, and this is the minimum value, so our final answer will be 1. So now we know what to do, and the idea is to use binary search, and at every iteration we assume the max difference, and we need to find the number of pairs that we can obtain given this max difference. So any pair that has difference less than or equal to the middle, that means we need to increase the count, and we need to increase I. Otherwise we just increase I here in the normal for loop condition, and if the counter is greater than or equal to the given p, that means this is a valid answer, so we set the answer to m, and we will look for smaller number to see if it can give us also an answer. So we move right equal m minus 1 and left equal m plus 1, and this is the middle value of every iteration. Now we start with L equal 0 and R equal 10 to the power 9. Also we set the answer to the maximum value, and it's 10 to the power 9 because this is given in the answer. In the constraints, the number is between 0 and 10 to the power 9. Assume we have number 0 and another number 10 to the power 9. The difference is 10 to the power 9. This is the maximum possible difference. This is why we set the answer to 10 to the power 9 and also the right value. And that's it. The time complexity for this is big O of log of 10 to the power 9 multiplied by length of the array, because we have this for loop.